So on your warm-up, so there was a few different problems just kind of assessing our knowledge of quadratics thus far before we move into today's lesson. So here, we know the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a, right? We usually plug into that. But in this problem, it's saying, hey, this person set up this equation. What must they have started with, right? So, well, we know the quadratic formula. We know it's y equals, I shouldn't say quadratic formula, quadratic standard form. Y equals ax squared plus bx plus c. So we just got to find a somewhere in there, b somewhere in there, and c somewhere in there. And since we know it's negative b, where's my b? It must be the 9, right? It's also b squared. So there's our b value. And then it's minus 4ac. So what's my a? 1. And then that means my c is 10. So that gives us all the pieces we would need to write our equation. So we would say y equals 1x squared, or just x squared, plus 9x plus 10. So that must have been the equation that Beth started with. Okay? All right, next one. It asked us to simplify this answer, right? So if you took the square root of 48 and you broke it down. Now this is something I don't think I've stressed enough. Sure, you want to look for perfect squares in there. So you could divide by 4. But if you divided by 4, you'd get square root of 4 times the square root of 12. And then you'd have to keep going, right? If you do that and you had to keep going and then you got square root of 4 again and square root of 3 and you got multiple perfect squares, what you could do, well, what you could realize at that point is there was a bigger perfect square in the first place, right? There was a number that I could have gone quicker with. So you could start over at that point if you wanted to and say, let me see if I can get a bigger perfect square in there. What bigger perfect square goes in? 16, right? And that's just going to make this a little easier on me because I know the square root of 16 is plus or minus 4. And then I get square root of 3. And then this simplifies to x equals 8 plus or minus 4 square root of 3 over 4. Now, I would have got the same thing here because this would have been plus or minus 2. This would have been plus or minus 2. 2 times 2 is 4. I would have got my 4 square root of 3. But that would have been a cleaner, quicker way, right? So if you feel like doing it the quickest way and you get multiples, you can start over and try to find that bigger one. That'll always be the case. All right, then I want to ask myself if I can simplify this. So I look at this number, and this number. And I ask myself, does anything go into all those? 4 does. So so I divide them each by 4, and I get x equals 2 plus or minus, and then 4 divided by 4 is 1, so just square root of 3, all over 4 divided by 4, which is 1, so it's just this. Okay, so that simplifies down. Okay? All right, last couple. It didn't ask you to do these. It just said, hey, what would you do? Let's talk about this one first. What form is this in? Vertex. So our only option there is isolate square and then square root, right? I would move the 7 over, divide by negative 3, square root both sides, and that would be my answer, right? Now this one, okay, so I'm looking at it. I know it's in what form? Standard. And then I say, oh, maybe there's a GCF because A is not 1, but there's not. So what are my options here? Rainbow or reverse box or quadratic formula. Now, here's the thing. Some of you like the quadratic formula. Some of you don't. What if you were one of those people who doesn't, and you were like, I wish I knew which one. I wish I knew if it was one of those ones you could use this. before I go start setting up the whole quadratic formula. Or maybe you got to the point in the rainbow method and you got stumped and you wanted to know, what tells us whether you can or not? The discriminant. So last lesson, we learned that we can actually figure that out. We can ask ourselves, well, let's find b squared minus 4ac, right? That would be 9 squared minus 4 times 2 times 7, or 81 minus, 56, which is 25. What does that number tell me besides the fact that I have two real solutions? It's 25. What kind of number is that? A perfect square, which means what? That means this works. That means I don't have to do the quadratic formula. Okay? That's why the discriminant is valuable, even beyond just knowing two real solutions, one real solution, two imaginary. Right? If I find this, I can go, oh, sweet, I don't have to do the whole quadratic formula. I can factor this. Right? So that's something you can use to help you. All right? All right, so what we're going to talk about today are projectiles. What? Projectiles? What is he talking about? What is a projectile?
Something you throw.
Yes, something you throw. Thank you for not actually throwing your calculator at me and just pretending.
An object suspended in air going through motion.
That has been thrown, right? Or launched, or catapulted, or somehow put into the air. Okay? So how does a projectile behave once you throw it into the air? It goes all the way up, and then it comes all the way down. What does that sound like to you?
Parabola.
A parabola. Yeah, it does. So, hey, we learned all this knowledge about how to find things in parabolas, or in quadratic equations, and use parabolas and all that stuff. Why not apply it? Why not use it? If somebody's launching a missile and they want it to hit a certain target, right? They do the math to figure out how to aim that missile, right? What do you think they use? I mean, it's much more complicated than what we're about to do, but they use the analysis of projectiles, and in some cases a quadratic formula, to analyze that, unless there are other factors, to analyze that that path, so they can plan, right? They can adjust. Okay, so we're going to talk about that. Okay, so let's start by just talking about this picture. Okay, because this is our standard form of the quadratic formula or equation, and we got x and y, but we're not really dealing with x and y here. This is our y, this is our x. What is our y in this situation? If you think about a projectile, it's our height, right? This is our height. So why not just use h? And then here's the other thing. This thing it starts here, it goes up, it gets to the top, and it goes down, and it hits the ground. What else changed? Not distance, although that is something you could measure another way. What else is changing?
Displacement.
Let me ask you this. It gets up to here, right? Does it get there instantaneously? No. What has to change? Time. So instead of x, we have time, or curly t. Just a t with a little curl on it. Okay? So.
Oh, God, no.
Oh, yes. Okay. So first thing we need to do is rewrite our equation with these new pieces. So instead of y, we have h equals a, instead of x, we have t squared plus b times t plus c. Yep, t squared. Right?
Oh, that makes sense.
Okay. Now, let's talk about the a, b, and c, because we're going to need to know those if we're going to write these equations, right? So our a value is gravity's pull. Okay? And it's going to be one of two numbers, right? If it's in meters, which is m, it's going to be negative 4.9. If it's in feet, which is ft, it's going to be negative 16. Anybody notice anything about both those numbers? They're both what?
Negative.
They're negative, and that's because, why?
Gravity pulls down.
Gravity pulls down, and also, why does it make sense when we look at our graph?
Because it's going down.
It's a flipped parabola, and we have a negative a, we flip our parabola, right? So negative always, right? All right, this b. Well, what else matters when we're shooting off a rocket? Yeah, the speed, and we use the word velocity, which I know is not the exact same thing as speed, but when you read the problems, it's gonna look like someone's giving you the speed. That's the velocity. Okay.
Why are we doing science and math?
Because science and math have a lot to do with each other, and learning the application. Because I like physics, and I don't get to teach it very often. All right. So, what about our c value? What would be, or what's our c usually?
Y-intercept?
Our y-intercept. So what is that in this case?
Unknown.
Starting height.
Yeah, this is our initial height. Very good. It's our initial height. It's wherever this thing was launched from. Maybe it was a 10-foot platform. Maybe it was the ground. Maybe it was my arm as I threw it, right? The height of my arm. So that's our initial height. Now, there's letters and things that we use for these, right? Our initial height is our h sub 0. That's just your height at time 0. Sub is like the opposite of an exponent. It goes down. So your height at 0, h sub 0. And our velocity is our velocity at time 0, or v sub 0. Okay?
Sub-zero.
Yep, sub 0. Okay, and then obviously h, we said, was our height. And t was our time. All right, so let's rewrite this equation one more time. And let's do it for meters and for feet. So for meters, well, h will equal, what was our a value always when we had meters? Negative 4.9 t squared plus, what was our b? V sub 0 t times t, right? And then plus h sub 0, our initial height. Okay? So that is your equation that you need to create if you're doing meters. If it's feet, it would be h equals negative 16 t squared plus v sub 0 t plus h sub 0.
Capital V or lowercase?
Capital V. Lowercase h. Just because I want to, All right, here's the thing. This right here, v sub 0 and h sub 0, will just be given in the problem. All right, so these two numbers are given in the problem. They will tell you these, you plug them in, and that gives you your equation. So you're not going to be like having to figure those out. That's just going to say, hey, here's the speed, here's the height, plug them in, make your equation. Okay? And then you're going to be asked to find things about this path of this situation. So what do you think we might be able to find with our knowledge of parabolas? The vertex, which, why would our vertex be a good thing to find? Yes, this is the maximum height. This is our max height. And at that max height, we will have a value of have a value of t comma h, which is the value that we want if we're looking for height? H. So it's the y value of your vertex, right? Or h value in this case. It's the h value, right? What other thing might we be able to figure out?
Where it lands?
Well, not where it lands, when it lands, right? We could figure out the time here where it lands, or when it lands. So what is this thing? X-intercept is when it lands, when it hits the ground. Right? So if you can find that, you can find out when it lands. Now, what is the height when it hits the ground?
0.
Which is a very important thing to know. H equals 0 at that point, and that's going to help you. Okay? Now, there's one thing that I got asked in every one of my classes today about this last piece. All right, so what about the x-intercepts? When we find x-intercepts, especially this type of parabola, how many do we find? 2. How do we know which one to use? So that's a very important point we need to make. Now, what do we know x is here? No, I mean, we changed x to t, which is time. So that means that this would be a...
It has to be the second one. That's negative. It can't be negative time.
Exactly. Keep going. Keep talking. Why is that true?
Because time can be like negative something. It has to be like 1 second to second to 2 minutes.
Do we see that, right? If time is negative here, reject it. It doesn't make any sense in the context of our problem. It's outside of our domain, all right? So we would reject, we'll get 2 answers, sure, but we're going to reject the one that's negative because it doesn't make any sense. You can't land at negative time. Question?
Yeah. If they were both not positive.
They wouldn't both be positive because your initial height would always be your starting point of time 0, right? So you might get 2 answers that are 0 and something. Well, you would know it's not 0 because that's when no time has gone by. It hasn't launched yet. Yeah?
Means we can also find the initial height is one of the things that we can find.
Yeah, we could also find our initial height, which is right here, our h sub 0, our initial height. Yeah?
I think a simpler explanation is why you can't go past the y-axis is because time travel is impossible.
Right, so we're not in a time travel movie, so no negative time. What's that?
Oh, Marty McFly, he proved you wrong.
Yes. Either Marty McFly or Tenet do not apply here. What if it's what? I can't even say that we only deal in the real here because we just did imaginary numbers. But in this case, we're just dealing with the real situation. Okay. All right. So those are all the things, right? So let's practice finding some. Okay. So let's move to this next problem, and this is the process, right? So Sal hits a baseball, right? Hits the baseball at 3 feet height is where his bat hits the ball. Hits it. It's a bomb, right? It's going to be up in the air for a while, right? We want to answer a couple questions. When will it hit the ground, and how high does it get? What's its max height? Okay? So we have to write our equation, and it says, first thing we want to notice is, oh, it's feet, right? It's feet per second. So we know which equation we're going to use. We're going to go h equals negative 16 t squared plus initial velocity t plus initial height. And then we got to ask ourselves, well, can I find these 2 things? What's my initial velocity? 88. And what is my initial height? 3. So I'm going to write this equation again. And I'll say h equals negative 16 t squared plus 88t plus 3. And that is the equation that we're going to work with here. Then it asks me, when will the ball hit the ground? Well, what is that asking about? That means h equals 0, so that's our, remember, look at the picture. Yeah, question or answer?
Since this is the height, won't we be dealing with gravity?
We account for gravity with our a. And it launches and gravity pulls the whole time. So our height will be 0. We make our height 0. We go 0 equals negative 16 t squared plus 88t plus 3. So we got to ask ourselves, how do you find a variable in a quadratic equation when it's all set equal to 0? Okay, let's answer this question first. How do you find a variable when you set a quadratic equation in standard form equal to 0 and the numbers are a little crazy? The quadratic formula. Question.
Is it always minus 16?
For feet. If it said meters, it would be minus 4.9.
So every time?
It's one of those two.
Every time A is like that?
Yeah, one of those two numbers. Luke?
Mine was basically the same.
Okay, yeah, negative 16 was because it was feet. That's why I highlighted feet. Okay, so we want to use the quadratic formula here. So I would say, okay, x equals negative 88 plus or minus the square root of 88 squared minus 4 times negative 16 times 3 all over 2 times negative 16. And you absolutely want to pick up a calculator. Figure out what that number is under there. So it becomes x equals, in the interest of time, we're running out, negative 8 plus or minus the square root of 7,936 divided by negative 32. Now, we're not looking for an answer like that. We want to have an answer like something, some seconds, right? So we have to pull this apart to get our two answers, okay? So I'm going to say, okay, x equals negative 88 plus the square root of 7,936 divided by negative 32, and x equals negative 88 minus the square root of 7,936 divided by negative 32. And I put those in my calculators. If I want to do it all at once, all you got to do is add some parentheses around this part and then divide by negative 32. I'm not going to ask you to do that right now. You'll practice that in your homework. Your answers you would get here would be x equals negative 0.03, and that would be seconds, right? Because we're looking for time. And the other answer would be x equals 5.5 seconds. So which one would actually make sense as when the baseball would hit the ground? 5.5. So that's our answer. And we reject this one. Okay? Now there's one other thing we might need to find, which is it's asking for the max height. So what is it asking us to find? What do we need to find? The vertex. So our vertex, in standard form, there's a couple ways to find it. You could complete the square to convert to vertex form. I've seen students do it. But you might want to just go x equals negative b over 2a to get your x. Plug that back in to get your y. In this case, if you did that, you'd get 2.75 seconds. That's how long it takes to get to its max height. That's not its max height. You plug that in to find its max height. So you would say h equals negative 16 times 2.75 squared plus 88 times 2.75 plus 3. And then if you put that all into your calculator, you would get 124. And of course, we're dealing with feet. So that is your max height. This is just your time, right? We use x because we're used to it in both cases, but it's your time. And then you plug it back in to find your height. That's your vertex, right? On your homework, it's going to ask you to draw a picture. It's very helpful. Draw the picture of what's happening, right? Label it. Now, there's one other thing, and then I'll finish, because there's this one special situation that seems to confuse students. So you have, look at this equation down here. A rocket is launched from the ground with an initial velocity of 200 meters per second, and it wants us to just set up the equation, okay? Whoops. So we're just going to set up the equation here, okay? So, well, we know h equals, it's meters, so it's negative 4.9 t squared plus the initial velocity times t, so that's what? 200 t. But here's the problem. It doesn't give us the initial height. Our initial height is what?
From the ground.
It's from the ground, so how tall is the ground? 0. So if you see from the ground, that means 0, and that means this is your entire equation. You don't have to add 0 to the end of it. Okay, so if that shows up, that's what that's about. Okay? Just practice tonight. I know the numbers get a little crazy. Use your calculator. Help yourself out.